The binomial theorem looks very complex in the beginning when introduced to students. However, it comes very handy when you want to expand really complex brackets and so on. So this video is going to look into the basics of how to expand brackets using the binomial theorem. So binomial just means that you have two terms inside a bracket, and the theorem is used when these two terms are raised to a specific power. So this is what the theorem is, and if you'd notice, we're using combinatorics here in the beginning, and we have the first term being used and the second term being used, and then powers all over. Now this whole thing could be simplified to the sigma notation. And it seems really complex this way, but we'll get back to it once we do an example. So once you understand it through an example, then this formula will make sense, especially if you want to refer to it during an exam. So let's look at this expansion. So x plus 2 to the power of 5. If you want to expand it completely on your own, it's going to take a really long time, and you might even make mistakes. So the binomial theorem comes in three parts. The binomial coefficient here, which we're going to use combinatorics for. This is your first term, and this is your second term. So always take the first term, put it separately, and then the second term including the sign in front of it, and that's going to be your second column. Now you can use a table format like I'm going to do in this example, but then you will be able to completely write it in one line if you want to. So next what we're going to do is we're going to take this power, this is going to be our main power 5, and we're going to decrease the power of x. So we're going to start x to the power 5, x to the power 4, 3, 2, 1, and 0. It's actually decreasing the power of anything in this cell. And then what we're going to do with the plus 2 is we're going to do the opposite. We're going to start with a power of 0 and go all the way to 5. So 0, 1, 2, 3, 4, 5. Now the binomial coefficients, we are going to do the same thing. The n is going to be 5 because that's the power we have, and then the r is going to increase 0, 1, 2, 3, 4, 5. Now if you remember facts from combinatorics are symmetrical. It means that if I start at 5, 4, 3, 2, 1, 0, it won't matter, it will still give you the same value. Even these if you switch them around, but make sure that one of the terms is increasing and the other term is decreasing. We could have swapped them around. Also make sure that you take the correct sign here. Now once we have that, we're going to simplify it. So we can use our calculator to evaluate 5 choose 0, 5 choose 1, 5 choose 2, and so on. You can use the calculator for this. We're also going to simplify these values, and it's going to give us this table. So then we're going to simplify it. So we're going to go 1 times x to the power of 5 times 1. That's going to be x to the power of 5, and so on. So what you want to do is multiply all the numbers together. So if I see numbers, I'll multiply it together, and then simplify any powers you might have. So I'm going to get this simplified. You can pause the video and see how I got to this step. So now this is actually the answer of the expansion. What this process does, the binomial theorem, is that it already expands it and simplifies it for you. So it's all done nicely. And now I can just bring them all together here, and that will be my expansion. So I'm just going to bring them here, and I'm going to put a plus sign between them unless there's a negative there. So I'm going to explain that on the next slide. So go back a few minutes in the video just to see again how I did it, but that's basically the binomial theorem. And you can apply it to any powers with any terms inside the bracket. It always follows the same step. Okay, let's do another example. This time there are like 2 letters and there's a negative in there. So again, if you notice, I'm picking the first term here, and then I'm putting the second term with a negative in there. So the first term is going to decrease in power, and notice how the bracket, the 6 power belongs to the 3 and the 6. So if you're going to use rules of exponents, this 6 is going to be the power of 3 and the power of x. So that will happen in the next table. And the same thing with the negative 2y. Be careful, it's a negative, so you need to put the whole thing in a bracket and also raise it to a power. The binomial coefficient this time will start with a 6. The n is going to be a 6, and the r is going to go from 0 to 6. So again, that's based on the power of the expansion you have. This is the 6 that we have. So I'm going to simplify it. Again, the left hand, the binomial coefficient I can use from the calculator. The x, notice how I'm raising the 3 to the power of 6 and the x to the power of 6 and so on. 3 to the power of 2, x to the power of 2, and going forward. And then keep in mind that anything to the power of 0 is 1. Now for the negative 2y, be careful that you have a negative power, and when you have, you have a negative value here, and any negative raised to an odd power will give you a negative. So notice how the odd powers have negatives next to them. So that's something to note. But negative 2, so you're spreading the powers here in case you're unsure. So let me take this out, for example. This is going to be a negative 2 squared and a y squared. So a negative 2 squared is just 4 and then y squared, which is why we're getting the positive 4y squared. Make sure that you put the correct sign in there. Now, once we do that, we're going to simplify again. So remember to multiply the numbers. So 1 times 486 times 1, put it there. 6 times 162 times negative 2, put it as a coefficient. And then x to the power of 5 and y will just be combined together. So you'll get something like this. So again, 20 times 27 times negative 8, that's negative 4,320. The x cubed and the y cubed will just remain as they are. And just double check that you get the correct signs, that you have the x decreasing in power and the y increasing in power. And again, bring them in, but this time you're not going to add them all together because this will be a subtraction. So if you notice, it's 486x to the power of 6 minus 1,994 x to the power of 5y. So I didn't have to put a plus in there. You could put a plus in there if you want to. You're adding all the terms together. But because this is a negative term, it's just going to be a subtraction sign in there. It would still be correct if you put a positive. So that's it. That's how you use the binomial theorem. So let's look back at the theorem itself to make sense of all the things we've done. So what this tells you is, notice how the combinatorics, the r is increasing, which is what we've done in the first row. The first term starts with the n power and it decreases in power until it reaches a power of 0. Our second term starts, there's nothing here because it's to the power of 0, but our second term, which is x in this case, starts with a power of 1 and it increases until it reaches a power of n. So that's what we did basically. So it was like, this is the first column, this was the second column, and this was the third column. And the first term was decreasing in power and the second term was increasing in power. And the summation here just basically simplified this. So this is basically adding all the rows together. So, and using sigma notation, you're going to substitute 0 first. So I can write like a 0, a 0, a 0. And then in my next step, I'm going to replace it with a 1, a 1, a 1, and so on. So basically, this is the summary of it. So this is the first column, second column, third column. The power here is decreasing, the power here is increasing, and the power here and the r here changes as well to increases. And we start from 0 and we end at n. So hopefully you can make the link between the sigma notation, the binomial theorem, and what we've done in the example. But main thing to remember are the steps and also the signs, making sure that you select the correct signs and any negatives you might face.